Alright, so we're just going to have a look at this set, which is about determining quadratic rules given graphs or other information. You can see here we've got a red graph that hasn't been translated, and there's 1 point on the graph which is at 2, 5. So we're going to have a look at how to do this one. Alright, so the first thing to do is to have a think about what different forms of quadratics we know. Now, we know that there are forms that look like this, plus k. We know that there are forms that look like this. We know that there are forms that look like this. So let's have a look at the information we've been given and can read from the graph, and we'll decide on a form to use to try and work out the equation of this quadratic. So this graph, we can see here that the turning point is on the origin, and we have one other point. Alright, so let's have a look at the three different forms we've got. This one here tells us the y-intercept, which we do know, c is equal to 0. The second form tells us the x-intercepts, which we do know also. And the third form tells us the location of the turning point, which we also know. So on the face of it, it seems we could use any of the three forms, but I'm going to choose the first one because this equation, or the parabola here, is actually, it hasn't moved, which means that h and k are going to be 0. So knowing that, I'm going to write out our equation, and it's going to look like this. Because h and k are 0, it hasn't moved. What we can do now is to use this second point they've given us, which is 2, 5, substitute it in place of y and x, and solve for a. So we have 5 equals a bracket 2 squared, 5 equals a bracket 4. 5 over 4 equals a. Alright, now this has taken us straight to this dilation factor of a and allowed us to find the equation of this parabola. So our last step is to write the equation in the original form using y and x. This tells us, if we looked at this equation, this tells us that it has no horizontal or vertical translation, which we can see from the graph, and it tells us the dilation factor is 5 over 4, which is bigger than 1, so it means it's a little bit fatter than the regular equation of y equals x squared. Alright, don't forget that this a value here is 1, so 5/4 means it's been pushed outwards. Alright, now in this one, you can see that there's a few things that have changed. It's turned over to be a negative parabola. It's been moved up, so it has a y-intercept of 3, and we don't know about the dilation factor. So again, I'm going to choose the equation of the form this, and I'm going to say that it's been moved up. I can clearly see that there's no horizontal translation because this turning point here is at 0. So I'm going to sub in the y-intercept of 3 in place of c, so my equation is starting to take shape, starting to look like this. And then the last step is to use this second point here and sub them into place of x and y, like we did before, to solve for a. Alright, so move this 3 across to become minus 3, so minus 2 equals 9a. And then I'm going to divide by 9 and get an a value of minus 2/9 equals a. Now my last step is to substitute those values back into the original equation, which is this. So y equals minus 2/9 x squared plus 3. Now let's just have a quick look at that and see if that makes sense. The negative a value means the parabola has been turned over, which we can see. 2/9 means that it's dilated, become closer to the y-axis, which we can't really see. And plus 3 means that the turning point has moved up to 3 and goes through the y-axis there. So this all makes sense. Alright, in this third example, we can see here that this quadratic has had both horizontal translation moving across and vertical translation moving up. So the form we're going to choose is going to be a x minus h squared plus k. Now, it's up to us to try and read the information from the graph and find out, if we can, what information to plug in. So let's see. The turning point is at 1, 6. So we know from experience that the x value sits inside the brackets there, and the k value sits outside the brackets there. Oops, sorry. I put a +1 there. That should be a -1 to show that it moves to the right. Oh, and that should be a +6. Alright, now the last thing to do is to find out this a value, and this is why there's another point here. So we're going to substitute that value into x and y, and then simplify and solve. So this is going to become -1 squared plus 6, 8 equals a plus 6, minus the 6 from both sides, 2 equals a. So therefore, the final equation is along the lines of 2x minus 1 squared plus 6. And if we try and read the information out of this final equation and match it to the graph, we can see that there's a dilation factor of 2, which we can't really match. There's been a horizontal translation of 1 and a vertical translation of 6. You might notice at this point here is the y-intercept. So if you wanted to, another way could have been to try and use the general form of the equation, but I won't go into that now. Alright, in this final example you can see that the parabola is completely different from the other three. It's had horizontal translation, vertical translation, but we don't know where the turning point is. All we know is where the x-intercepts are, which means we're going to have to change the form we use. So we're going to try and use intercept form, which looks like this. Alright, now we don't know what a is. We know what the x-intercepts are though, so we can put those in. So we just one at a time plug them in. So x minus 0, which is the initial one, and x minus 3. Now remember, it has to be a -3 to show that it goes to the right, because when you solve it using the null factor law, it will come out as being +3. Alright, now the final step is to use this other point that they've given us and put it in place of x and y to solve for the a value. So we're just going to substitute that in place there. -1 minus 0, -1 minus 3. Keep in mind that the -1 goes in place of both x's in the initial equation, not just one of them. Simplify away, you end up with -1 times -4, 8 equals a bracket 4, divide by 4, and you end up with 2 equals a. Plug that back into the initial equation, which is on this line here, and you end up with your final equation of the parabola. Notice that I've taken out the x minus 0 because we don't actually need it. It doesn't change anything in the answer. If you wanted to, you could simplify the first two terms to look like this. And if you wanted to, you could simplify it even further and convert it into general form, which would look like that.